It is now 14 CEST and we can slowly start the webinar. Welcome everybody who has joined already now to the CRiceS webinar on impacts of climate change in polar regions. First of all, please note that the webinar will be recorded for future use. So, we have today 1 hour for a very interesting webinar. I will just say a few words here at the beginning about the CRiceS itself before I let the actual speakers of the session tend to go into details. I think it's 1 minute past, so I will start now. Maybe some people will join a little bit later. I am Risto Makkonen from Finnish Meteorological Institute. I am co-coordinating the project with the Jenny Thomas, who you can also see here as a panelist. We are now in the second year of our 4-year project, focusing on sea ice and snow in the polar and global climate system. You can see our project website here. Please go and have a look already if you are interested in more details what we are doing. As we know, the polar regions themselves are experiencing some of the most rapid climatic changes within the Earth system. This is manifested in dramatic warming, of course very visible in loss of sea ice and variability of sea ice at both poles and changing oceans. Arctic sea ice continues to decline and throughout the year, and there's a shift to a younger, thinner sea ice. In the Antarctic, the climate models cannot really reproduce the observed variability or trends. There is a very low confidence in the ability of our current Earth system and climate models to really contain all the processes what are happening in the Earth system in the polar regions, and that's why we have also CRiceS project to improve the climate model capabilities. We are a heavily climate model focused project. We do have a very strong observational group in the project also, but one of our main aims is to improve global climate models in various perspectives. You can see our core themes where we improve the models here on the right hand side. Our first core theme is focusing on heat, mass and momentum exchanges in the polar systems. CT2, core theme 2 here, focusing on aerosols, clouds and precipitation cycle. Core theme 3, looking at the biochemistry both in ocean and sea ice, and for example linkages to the greenhouse gas exchanges. And then we focus on the overall coupled system behavior connecting all of these other 3 core themes. We bring together 20 partners from 14 countries. In addition to our European partners that you can see here in this picture, there is also partners from Canada, India and South Africa. So please, if you are interested in learning more who are the teams and the actual people working in the project, or you want to learn more about the core themes that we are tackling, go to our project website and also for example, follow our active Twitter feed to see more recent news from the project. So, back to today's topic. Today's topic is the impact of climate change in polar regions, and we focus now on linking sensitivities to hazards for improved understanding of climate risk. We are already interested in your input for major knowledge gaps regarding polar regions in climate adaptation, and we hope that you can give feedback with the Zoom polls and quizzes. So we will now activate a poll in the Zoom system. So now I think you should have the opportunity to provide input on what are the major knowledge gaps for climate adaptation in the polar regions. So we will get back to this later in the webinar, so please fill it in already. Also, use the question and answers if you want to ask something from the presenters, and you can do it already during the presentations, and we will go through the questions after the two presentations. So now everything is set up, we will go to our first speaker. Our first talk is by Bjørn Samset. Bjørn is a senior researcher at CICERO, which is Center for International Climate Research in Oslo. He works on global climate modeling with focus on the effects of atmospheric aerosols and natural variations in the climate. He was recently coordinating lead author on the IPCC Sixth Assessment Report and active communicator of climate science to policymakers and the public. Bjørn is also in CRiceS working with climate models and aerosols, and today he is presenting on climate hazards, physical changes in the polar regions. Go ahead, Bjørn, the floor is yours.
Thank you, Risto. Thank you for opening and so for coordinating the project, and thanks to everyone else for coming to this webinar. We will have two presentations. So I will start, and then Stefan will be talking after me, and we will gradually move from physical hazards, so physical changes in the Arctic, or the polar regions, what we know and what can happen, towards actual risk assessments. And I'll remind you in a minute what that is. I start this with a picture of something that is not directly related to sea ice and snow, which is the main topic of CRiceS, which is a fire which occurred very recently, and which is another example of major changes going on within the near to or within the Arctic Circle. This ever-increasing rates of large wildfires in new regions and at new times of the year. And I'll show you in a bit why I start with a fire rather than sea ice, because as with everything in the climate system, everything in the Arctic is connected. So if we take one step back, it's no surprise to anyone here, this overall conclusion from climate science for a long time, that our climate is changing. It is changing rapidly, it is changing massively, and it is changing mainly due to historical and continued human emissions of greenhouse gases. We know this, we've known this for several decades. This was also the conclusion from the first part of the last IPCC report. If we then look to the second part of the last IPCC report, to Working Group 2, we're looking at the impacts of climate change and how we can adapt, then they have a cross-chapter paper on the polar regions specifically, where they summarize all our knowledge of the impacts, or the scientific knowledge of the impacts of climate change on the polar regions up until today. And they start that with this very stark quote. They say that the polar regions, and notably the Arctic and the maritime Antarctic, they are experiencing impacts from climate change at magnitudes and rates that are among the highest in the world. And note this, they will become profoundly different in the near-term future, that is by 2050, under all warming scenarios. And that means that we will see polar regions that change, that transition into a new state regardless of what we do. Of course, we can still affect how rapidly the changes occur and how large they will be. But we have to accept, unfortunately, that there will be major changes in the polar regions. So that, of course, begs the question, what does this mean then for local communities, for nature in the polar regions, for industry, other activities? Well, that is, to answer that, then we need full risk assessment. The IPCC partly does this as well, but also just acknowledging and respecting that this is not something that science can answer fully on its own. This is where we need the knowledge and the input of the indigenous communities, of the industrial activities, of people studying nature in the polar regions, etc. So you see on the right there what we call the risk paddle, which are all the components of a full risk assessment. So you need to know how vulnerable we are to various changes. You need to know how exposed we are, how we respond to the changes, which also affect the risk. But then, crucially, we do have to start with what we call hazards, which is simply the physical change. So what is it actually physically that is changing and that we then may or may not be vulnerable to or exposed to? So then, again, a quick reminder that on a global basis, the IPCC assessed that extreme heat not only becomes more frequent and more intense, but we know that this is now for all regions of the world because of our warming, our emissions. Same thing goes for heavy rainfall. It's more frequent and more intense, but mainly in the regions that were already exposed to heavy rainfall. Same thing with drought. Regions that were previously dry, they are getting drier. We see fire weather in new regions. We see fire weather at new times of year. And we see major changes to all the world's oceans. That includes warming, acidification, and losing oxygen. These were the headline conclusions from the physical science part of the last IPCC report. But of course, these changes have to be modulated by which region you're looking at. And the Arctic, as we know in particular, is special. It is changing rapidly and is changing differently to the rest of the world. So if we look a little bit then at the maps of how things are changing, you immediately see this reminder that the Arctic is warming, first of all, faster than any place on Earth. So the three topmost maps on the left, they show what we expect for the pattern of global warming at first 1.5 degrees of global warming, which we're rapidly heading towards, then 2 degrees, and then 4 degrees. Of course, on top of the ever reddening pattern, you see how the Arctic is warming much faster than the rest of the world. This is well known. But then in the second row, you see also how this the similar picture for mean annual precipitation, so rainfall. And you can see a very greening top part of the world and also bottom part. The polar regions are also getting wetter. This is again no surprise because the entire hydrological cycle is getting more intense. So there's more water evaporating both from land and from the oceans, and that water has to go somewhere. And a lot of it is transported with the winds towards the Arctic. So we can expect a warmer and a wetter Arctic and also southern polar region. But then there are also many changes that are unique to the polar regions, and the typical or the most commonly discussed one, of course, being the Arctic September sea ice. There are, of course, many others, but this graph shows or documents this conclusion from the IPCC that you will see major changes no matter the emissions. So the black line on the right there for the sea ice shows the sea ice decline up until 2015. And then the red lines, they show the future scenarios under various assumptions. So the light blue is for very low emissions, the dark blue is for very high emissions. And you see that they do start to spread later on in the century, which means that we can affect the future evolution of the polar sea ice. But up until around 2050, they all follow about the same trajectory. This is because of the magnitude of the changes we have already started and the fact that the world will continue to warm. Now, these are simple examples, which most of you probably know very well already, but they then lead into this summary, which is a lot more complex. So this is from chapter 12 of the working group 1 of the last IPCC report, where that's a chapter on regional risk information. So how do these various physical hazards or physical changes play out in the different parts of the world? So here, and don't worry, I will talk you through this one, and we will use a specific example in a minute. The columns here, they show various different physical drivers. So they're hot and cold drivers, things like the mean temperature, extreme heat, cold spells, frost days. Then you have things related to whether it's wet or dry, so dry periods or extreme rainfall. You can have changes in wind. You can have changes in the amount of snow and ice. You can have changes in coastal conditions and also oceanic conditions like coastal flooding, ocean acidity, and other things like air pollution or the surface concentration of CO2. And then even within the polar regions, of course, these changes will not be the same in every region. So the Russian Arctic will be different to the East and West Northern America, very different to the Greenland ice sheet. And same for the different parts of Antarctica. So the IPCC produced a relatively comprehensive, as you can see, summary of how these physical changes play out in these different regions, with then some caveats. And where you see blue here in different shadings, we have good scientific knowledge that whatever the hazard is increasing. Where it's brown, it's something that's decreasing. I'll show you an example in a minute. This is just to tell you that there is all this information available, which goes beyond just the fact that there will be less sea ice, beyond the fact that there will be higher temperature and more precipitation. We can also now study and give information about all these various changes. And the IPCC also did that. And they identified in working group 2, this cross-chapter paper that I mentioned, they identified a set of what they regard as key risks for the polar areas and what the underlying hazards are. So there will be risks to, just to do the one on the top, risks to marine ecosystems and species. And this can be tied to, of course, warming, to marine heat waves, to sea ice loss, to glacial and ice sheet melt, ocean acidification, invasive species, and harmful algae blooms. Those are the physical changes on the right, leading to a risk to marine ecosystems and species on the left. And then you can continue down the list with the risk to terrestrial systems, risk to commercial and private infrastructure, risks to food and nutritional security, the consequences of increased polar shipping, increased mental health challenges and impacts on indigenous peoples, and risks from polar change for other global regions. So there has been this relatively detailed mapping. But we're still left with the questions, are these the right connections? Do these really tell us what we need to know about how climate change will play out as a risk in the polar regions? And again, I stress that this is not something that this kind of scientific mapping can answer on its own. We can give the first step, but we do need to talk and work with the local communities to figure out where the sensitivities are and where the exposure is. I want to add on another layer of complexity, because all I've spoken about so far are mean changes. So there will be on average warmer days, there will be on average more precipitation, will be on average more fire weather. But the face of climate change, the way we see it today, where we experience it, that is in unexpected, unprecedented conditions. There was a survey done by a website which was referred to in a paper from last year, which you can see in the middle there, which polled communities on what were the unusual or unexpected events in the Arctic for a given period. And you can see here what the communities answered. They were all related to extreme temperatures. That was the biggest category, maybe unsurprising because the Arctic is seeing a lot of heat waves, we know that. Changes in sea ice, obviously. The timing of the seasons, spring coming earlier, autumn lasting longer, things like that. The amount of snow, unusual species range. Species coming in at places where we are not used to seeing them or where nature is not adapted to having them. Changes in the permafrost, declines in species, and then also wildfires. Now, this increase in surprises should, in a sense, in itself not be a surprise, because one thing we know from science is that the probability of record-shattering events way beyond what we've seen so far, be it temperature or precipitation or other things, it depends on how fast the climate is changing. The more rapid the change, the higher the likelihood that you experience conditions way outside of what you've seen before. And of course, since we've already seen that the polar regions are changing the most rapidly, they're the most rapidly changing regions or region in the world. Of course, we will also have the highest risk there of these record-shattering extremes. And to the left, you see the right, you see the science version of this statement. That is, if you look at the variation of a hazard, say the maximum temperature, for instance, the warmest day, a heat wave, that can shift just to warmer temperatures. That's what you see on the top, just your standard Gaussian curve shifting upwards. But you can also have changes in variability, so that you don't have a shift in the mean, but you get both more hot days and more cold days, or the whole thing can change shape. Now, these are the kind of things that we are now trying to work on to understand how these underlying changes, beyond just the changes in the mean, can affect various regions, including the Arctic. That brings us back to this. Let me just pick out one. So fire weather in the Russian Arctic in particular. Now here we see that we have good confidence, it's blue, that fire weather, or the conditions for fires, will increase. But there are these numbers, so 2 and 3. That means that there's higher confidence in the southern regions compared to the north. And also that there's higher increase during some seasons, or higher confidence during some seasons than others. If we just look at reports from the media and also from measurements, we know from the last years that fires are on the move. They are moving ever further north, almost by the year, towards and across the Arctic Circle. They're burning in new areas every year, new times of year. There are fires that now do not go out properly in winter and burn all the way through the year. Of course, this is extremely important, both for the local communities where nature where the fires are, but also communities far away, because you get this long-range transport of fires. And this then links in with the loss of snow, like we study, and sea ice, which we study in CRiceS, because it means that if you lose snow, you also increase the probability of fires during winter when you're used to having snow. We saw an example of this in Norway just a few years back, which had enormous impacts for the local communities, and it is also happening elsewhere. So even though fires are not specifically studied or in the title of CRiceS, they are very relevant for their interaction with how sea ice changes. So then we need to work both on, if you can follow this flow chart to the left, which is from another paper a few years back. Stefan will show you more CRiceS relevant flow charts like this in the next talk. We can follow how climate change, global warming, leads to Arctic amplification, which leads to extremes more rapidly in the Arctic. But we also have to consider natural variability, how the variations in the climate system can lead to storms, which can also be influenced by climate change, for instance, and how that can lead to new extremes, and how all this can tie together into these unprecedented events. And that is what we work on. So we have a number of publications either on the way out or already out or coming soon, where we study these various indicators of climate change in the polar regions, and where we try to disentangle. So what is the actual driver? This technical graph is just from a paper coming out where we look specifically at fire weather in the boreal forest regions, where not just do we then look at the increase in fire weather, but what is driving it in the different regions. Is it the drought? Is it the heat? Is it the wind? Is it a combination? Is it natural variability more than changes in global warming? All these things occur in various regions. So that's the next level of physical information that we can give as a start to these kind of risk indicators. So in CRiceS, we focus on a broader range of hazards than just mean temperature and mean precipitation and mean sea ice. I think Stefan will show a longer list later, but they include things like minimum and maximum temperature, extreme rainfall events, of course, dry spells, growing season, onset and length, permafrost thickening and thawing. We can look at sea ice distribution through the year, extreme sea level events, fire weather, extreme burning events, changes in landscapes, etc. Then that leaves us with the question, when and where do these hazards change beyond what the local communities are adapted to? When does it become dangerous? Are these hazards changing faster than communities can adapt, or are we keeping pace with adaptation? What is the risk of events unprecedented in recorded history, and how would those impact local communities? And again, we're back to questions that we cannot answer, certainly not from the natural science side. We are dependent on knowledge of the actual communities in the region. So there I will end just by reminding you of this stark comment that the polar regions will become profoundly different in the near-term future under all warming conditions. That is now unfortunately locked in. And to understand the risk that this entails in the polar region, we need to study a broader set of hazards just on the physical science side, but then we need to link this to local and indigenous knowledge of vulnerability and exposure and of ongoing and future responses. And that is what we're trying to do with this webinar and with the other parts of the CRiceS project. Thank you. And I will take questions in the Q&A and we'll answer afterwards.
Thank you, Bjørn, for a very, very fruitful presentation, and I think I also learned a lot already so far. I hope that people can include questions now into Q&A, and we will take them after the next presentation. So let's now go to the second presentation of the webinar. So we have Stefan Fronzek, who is a senior researcher at the Climate Solutions Unit in the Finnish Environmental Institute. Stefan has more than 20 years of experience in climate change impact and vulnerability assessments, modeling of impact and adaptation, and climate and socioeconomic scenario development. Stefan is co-leading work package in CRiceS, and today he is talking about climate change impacts in the polar regions, indicator framing and case study analysis in the CRiceS project. Go ahead, Stefan.
All right, thank you very much, Risto, and yes, welcome, and nice to see such a large audience here in our webinar. And I follow directly on Bjørn's presentation with the same themes, and I'm actually planning to give two small presentations. So I first give a quick overview of how we want to address climate change impacts in the CRiceS project, and then I go a bit deeper into one specific case study that Claire Mozzoni, who's unfortunately not able to attend this webinar, has been started to work on. So the approaches in the CRiceS project to analyze climate impacts in polar regions, we have decided to frame this through an indicator-based approach, and we want to use indicators of the sort that Bjørn already introduced in his presentation, both to evaluate climate model simulations, and we can obviously start doing that with existing climate model information, but then, as Risto in the beginning introduced, also the CRiceS project will come up with improved climate model versions and will come up with new CRiceS simulations using Earth system models. So we also want to use these indicators to evaluate new and upcoming simulations in the project. For that reason, we also want to include and work with fairly simple indicators that can be directly calculated with climate data, and some of those might also potentially be linked with observations. And such a kind of simplistic or like a simple approach using indicators then also allows us to cover actually quite many sectors and many aspects, and hence it could also potentially provide an overview of climate change impact in polar regions through the use of indicators. And then we already heard Bjørn's presentation where at the end he was showing some first results from the CRiceS project. So there would be the case study applications of using climate impact driver indicators to study their distributions and also the rates of change. And that's work that has already been going on in the CRiceS project. In the second part of my presentation, I present more conceptual work where we look at the cascading effects and the cross-border dimensions of impacts in the Arctic and how they could penetrate through to other parts of the world. And then there will be also a couple of other case studies which will not be part of this webinar today. So the framework for climate indicators, Bjørn already introduced the IPCC risk framework with the 4 petals, and we actually realized that using that risk framework, it does not necessarily make it very easy to classify indicators, because some of the indicators might actually include several of the petals. So you cannot always disentangle very easily kind of the components of exposure, sensitivity, and vulnerability. In some cases, it is kind of integrated in indicators. So we therefore then took a very simple framing of climate impact indicators that distinguishes between the kind of the domination by a natural system, which is shown on this graph at the bottom, and on the other side of the scale is dominated by human systems. And then you might group these into 3 different types. So we would start with type 1 indicators, which would be the climate impact drivers or hazard indicators. Then type 2 would be indicators that are describing biophysical systems, and type 3 would be indicators that would go into socioeconomic consequences of these impacts. And obviously there's not a clear border between those, but this way we can describe sets of indicators that we have been working with. And then the difference between these indicators is often that the closer you go to the domination by natural systems, you tend to have more comprehensive data sources, And the closer you go to the socioeconomic consequences on the top of this graph, the more it is linked to actual policy development. So there are these two arrows on the graph. So working with this, we have reviewed some of the literature, or we started doing that, and we've came up with these fairly large tables that lists indicators. And these are very small. You cannot read those. Some of those Bjørn showed in one of his slides, and I actually only want to pop this up very quickly to indicate to you that climate impact drivers, some of these indicators are actually very well established and have been used in the literature for quite a while already. But then we are able to do new work with those. But then the biophysical indicators and the socioeconomic indicators, they tend to be kind of less established in terms of concrete sets of indicators. So we are reviewing the literature, trying to group these and describe these in terms of their relevance for polar regions. So that's the work that is going on in CRiceS, and we started this but we hope also that at some point we will be able to reach out to the larger community to ask for feedback. Which leads me to the second part of the presentation, which is a case study we have been carried out in conjunction with another EU project called CASCADES, which started 2 years earlier to CRiceS, which is called Cascading Climate Risks Towards Adaptive and Resilient European Societies. And in that project, we were kind of laying the conceptual foundation of looking at cross-border impacts of climate change. And the CRiceS project then allowed us to, or is now allowing us to use the Arctic as a case study and then explore these concepts that we have started defining in the Cascades project. So this is truly a collaboration between these two projects, and obviously because Cascades is ending this year, CRiceS then allows us to continue with that research a bit further. So I start with the conceptual framework that we developed that distinguishes impacts from responses. And on the left-hand side, you can see what is a typical, like a conventional assessment of climate change impact is that you have an impact in one region and response to those impacts happening within the same region. So you can see here is a conceptual border, impacts and responses are in the same region. But in a cross-border assessment, there is an impact of climate change happening in one region, and that may have penetration, cascading effects that may also cross borders and is then affecting actors in another region, and from which responses are required. So you both have an impact transmission and then also a response transmission to these impacts originating from another region. And we conceptualize these by defining what we call a climate trigger, which can be either a weather shock or a slow onset event, which is causing an initial impact in one region. And this initial impact then can have cascading effects, which are shown here in the blue boxes, which can can create a very complex system of cascading events, or sometimes it's also a very linear or simple chain of events. And that can then at the end cause an aggregate or net impact that is being transmitted to another region, and for which it is this poses a risk for the recipient region. And then we also defined what we called the response transmission system, which is indicated here in the green areas, where the response from the recipient risk actors can be targeted at any elements of the impact transmission, or also to external elements. I don't want to go too much into detail, but I now want to also, we obviously add that somewhere along the line we may also cross borders, and that's where the cross-border dimension comes into play. And then I go to the actual topic, which is a case study for the Arctic region we've been started to work on, and we came up with this rather complex diagram. And You can see here on top the climate triggers, which we identified. Regional warming trend, obviously, as we just heard, is much stronger in the Arctic than in the rest of the world. There is an increased precipitation as rain. We've also seen that on the maps that Bjørn showed. And there's also an increase of some extreme weather events, such as fire risk. And then we see a whole range of different impacts happening in the Arctic. And I'm not going into details of all of those, but an obvious one is the sea ice retreat. And Bjørn talked a lot about the wildfires, which is shown on this diagram here, which then can have different cascading effects. Sea ice retreat is obviously affecting shipping. It also affects tourism. It may also directly, also indirectly affect mining, and it can also affect fishing. And as a result of those cascading effects, there may be risks posed to linked to security, which is a topic that obviously, since the Russian invasion to the Ukraine, becomes very evident, and the Arctic discussions and NATO activities you can hear about nearly every evening in the news. There are risks related to trade, risks linked to finance, risks of migration of population, and for the Arctic, obviously, of special relevance is also the risk of indigenous people livelihoods. And there are many things going on, and of course one can kind of study each individual link here in this diagram in detail. I don't have the time to do this here now, but we have done this analysis using, we have conducted interviews, 27 interviews over the last 2 years with different actors from the European Arctic stakeholders, from Finland, Norway, Denmark, the EU, and indigenous group, and explored kind of the themes and especially the possible policy responses to the cascading effects from a European perspective. And the results of these interviews is that we studied the coherence of EU policies, and we found that these EU policies, they are actually quite coherent in terms of the objectives they define for the climate risks in the Arctic, but they often lack a long-term adaptation plan to go from the theory to real implementation. The main power that is coming from the EU is R&D activities that have been mentioned by many of the interviews. Then what has also been discussed in the interviews was the involvement of indigenous people, was mentioned in many interviews, but these communities, they often lack the time and resources and need to juggle between their daily lives and participation in national or international research and development projects. Then the analysis of the influence of non-climatic drivers in relation to energy and security, and the conceptualizing of and setting off after the start of the war in the Ukraine is obviously also a topic that was very, very important in these interviews. So to conclude with these slides is we are studying the Arctic as an example where local changes caused by climate change can have global impacts, and they therefore need a very wide policy response to achieve adaptation to these impacts. The strengthening of policy coherence requires that all policy domains increase their awareness of the potential cross-border impacts of climate change, and for indigenous communities, borders are actually quite a different concepts, and indigenous communities' participation in developing policies for adaptation is very fundamental. Policy coherence cannot solve the issue of who has the power in the Arctic, and this will be a challenge for all policies attempting to address cross-border impacts of climate change. And with that, I thank you very much for the attention, and I would also be happy to receive comments and questions in the Q&A part.
Thank you, Stefan, for a very interesting talk. So, as Stefan mentioned, now there is the Q&A is still open. So please, if you have any questions to the speakers, click on the Q&A and insert your question there. But in the meantime, I think I will give the floor to Astrid, and maybe we will go to look at the poll that was submitted earlier in the Zoom.
Yes, thank you. I just also posted to everyone that if you haven't done the poll, please feel free to do so in a couple of more minutes, and then we'll end it and I'll check the results and see if what kind of feedbacks we got there. But before because we haven't got any questions yet, but I would like to ask Bjørn or Stefan, or if you have some comments on each other's presentations, or if there's anything else that you would have liked to say that you didn't get to say so far. I don't know, Bjørn, if we will start with you.
Yeah, I guess maybe I can challenge you, Stefan, then on the same kind of issue that we are posing. I mean, we were partly doing both this webinar and the later stakeholder workshop to try and get in contact with the communities that can tell us about the sensitivities. But where would you say, Stefan, that it is the most critical area for us to hear from the indigenous communities beyond what exists in the literature already, or local businesses or whomever is operating in the Arctic? So where is our knowledge gap?
Yes, yeah, good question. I'm not quite sure I have a good answer to that question. It's I think what was shown in my slides and what came out of these interviews involving indigenous communities, I think it's very important, but I think they are quite very often also overwhelmed by kind of EU projects dragging them here and there. So it's I think we need to be realistic in terms of kind of not asking too much of their time input for our research projects without getting very much back, I think. Having said that, I think the approach that we have chosen in the CRiceS project to focus on indicators, and well, the framing that we're using, this is one framing, or you could use other framings, I guess. It's maybe something which potentially could provide very nice overview of that affects not only the indigenous communities, but actually kind of like the whole society, and maybe with the case study that I now presented on the cross-border effects, it also demonstrates very much that even though in the Arctic there may not be so many people living, I think it's all of Europe and the EU and all of the world that is really affected. That's maybe my answer to that.
Thank you, Stefan.
Thank you both Bjørn and Stefan. We have gotten a couple of questions. The first one sounds easy, but I'm not sure if it has an easy answer. When are ice-free summers in the Arctic likely to happen?
So maybe I can pick up that, and I think the second one is more for Stefan. So of course the key word here is likely. Right? I mean, we of course do not know, but we have relatively good measurements now of the evolution of the sea ice in summer, so up to September, over a long time, and we can use that as a trend. And if we manage to reduce emissions to such an extent that we do not go above 2 degrees of global warming, then we may actually not see ice-free summers in the Arctic at all. Depending on, I mean, there's always variability. So there's a risk of ice-free summers, according to the climate models, actually starting already now. It's small, but it will keep increasing. But the average conditions then under the say good future outcomes, where we manage to restrain global warming, we may retain ice in summer. Though if we go above, if we follow the trajectory that we are currently on with current policies, and we're moving towards 2.5 to 3 degrees of warming, then the likelihood of ice-free summers becomes relatively high already around 2050. So that's really the deciding time frame is beyond. It's up to 2050, where everything is going to continues about the same, and then whether the evolution continues beyond 2050. And just to be scientifically precise here, what we mean by ice-free, the definition that we usually use is about 1 million square kilometers of ice, which can be distributed around. It will never be totally ice-free, hopefully, but that is so little sea ice that you will just consider the ocean parts ice-free.
Thank you, Bjørn. And then we have another one, which I guess Stefan might try to answer first. When we talk about adaptation, what is the frame we have in mind? Arctic, global, other. For whom is climate change adaptation? Who should carry out mitigation measures?
Yes, very good question. I actually have one comment on Bjørn's answer, if I may say that first. I think also for the sea ice or ice-free summers in the Arctic, I guess what is also quite important is also what's happening in the winter. And like if you think about shipping, will there be like, it's not only do we have a couple of days or weeks when we define them as ice-free in the summer, but it's really the condition throughout the whole year that will then cause important impacts. And then the good question about adaptation and Arctic, global, or what else. I guess adaptation is often kind of defined and thought of as rather local or regional. So it's kind of people and communities and activities are impacted at the local to regional scale, and that's where you need to adapt. But I guess maybe the slides that I showed on the cascading cross-border risk, they also demonstrate that there's a global dimension to it. So it's not only that you need to adapt to the impacts that are happening in your own backyard, but maybe there are things happening that also affect you from actually quite far away. So that there's maybe that dimension to adaptation is not only for those directly affected, but it's beyond that. And then for whom is climate change adaptation and who should carry out mitigation measures? Well, I think mitigation is for all. I mean, that is quite clear. And adaptation, I think yes, it is local, but I think there needs to be stronger coordination, stronger working together. I think that's maybe, I'm not quite sure how I could make that very much more concrete, but I think there is this dimension. We need to act local, but it cannot stay on that level. That would be maybe my take on that. Maybe Bjørn has to add something to that. Or?
No, I think I generally agree. I mean, the Paris Agreement speaks of common but differentiated responsibilities. I mean, we're all in this together, and we've all, to smaller or larger extent, been part of causing it. But of course, the responsibilities aren't equal, and the contribution to climate change today is also not equal. So mitigation has some spread, but the impacts, the adaptation, as you say, mostly does have to happen locally. But there can, of course, be help for this given.
And I guess one challenge with adaptation is then maybe also that it's not easy to measure progress in adaptation. So it's with mitigation, I guess we developed tools that allow us to kind of compare numbers, and you can see whether it's going, whether we're in the right direction or not. But kind of the monitoring of adaptation progress is obviously a topic of ongoing debate, but there isn't a clear answer, like a simple answer to that.
I guess it's harder to kind of measure those things that didn't happen because you were prepared or have done your adaptation measures in a proper way. I think now if Bjørn and Stefan, you don't have any more comments to these two questions, let's see if we can manage to close the poll to see if we got any questions. I'll try to end it and see what happens, if we can actually get the answers. Erik, would you like to help me with share those answers we got?
It looks like you already are sharing.
Did the rest of you see them?
No.
Okay, I'll stop sharing it and see if you can help me.
View results. You see, view details. Yeah, I can share. Just hold on.
While we did that, there was another, while we're trying to figure it out, there was another question coming up. You haven't spoken much about response. Could you add more detail on what response means in your assessment? Response to crisis/emergencies or larger response activities?
This was very small. I guess I have to read them, I guess.
But maybe Bjørn and Stefan, if you start by answering the last question that came now.
Yeah, I can. Oh, Bjørn, do you want to say?
No,
something?
I was going to ask you to go.
Okay. Yes. Yeah. Well. Yeah. Emergency response, but it's really all of it. I mean, all responses that you may need to have. So, like if you think about changes in sea ice extent in the Arctic, and then as a result of that increased shipping routes, then well, the whole trade system is affected. So then the companies doing that trade, they want to maybe take benefit from this opportunity. They react to that you can regard as an adaptation. Maybe yeah, that's maybe one example. But then also, if there are climate change impacts that cause a catastrophe, then obviously it's emergency response that is part of that. But I think there are all types of different responses are there, and some of those you may directly call adaptation. I think some of the responses are probably not labeled adaptation, but actually may be adaptation. I wonder. Bjørn, do you have any other thought on that? Or?
No, I would say generally the same. I mean, it's difficult to disentangle the terms. Maybe adaptation is a bit more proactive in a sense. Response is what we do if we haven't thought it through to begin with. I guess maybe one thing we should say to all of this is that adaptation and response, I mean, none of these are new things, right? We've always been adapting, and in particular in the north. I mean, it's not the first time that the polar regions are changing rapidly. So it's not that we're unused to changing climate conditions. It's also an area of very high internal variability. But what is happening now is then what we're showing both in CRiceS and elsewhere is that the changes now, they are more rapid and they're way outside of what the communities have adapted to before. So it doesn't mean we can't learn from previous adaptation efforts, but even there, the responses have to be higher and more rapid, which just means that we have to be better prepared.
Thank you both. And as you can see now, we have some of the feedbacks. And the first one is when it comes to knowledge gaps for climate adaptation by whom and where, and biodiversity and nature dynamics, interaction with climate. And the last one, and the funny one, just testing that we can join, and they can. And processes connected with sea ice cover and their effect on ocean atmosphere energy fluxes. Is this more or less what you thought were knowledge gaps?
They certainly list some of the two major ones here. So I think we already discussed the top one, but the two other ones, I mean, processes connected with the ocean atmosphere energy fluxes and sea ice cover. I mean, that is, say, luckily that is part of the core question of CRiceS in itself, and we were certainly aware that there are knowledge gaps there, and we're trying to improve the representation of those processes in the climate models. And the question then, of course, is what will that have to say for the quantification of the hazards and then the risks down the line? So these are things we're working on in CRiceS, but that's a long way to go. Like so many other things, it's the first time we are, say, actively changing the Arctic in this way, even though it was unintended, which means that we really do not know what is anthropogenic change, what is natural variability, and how these interlink. And that is particularly visible in these kind of detailed questions like the ocean atmosphere energy fluxes. When it comes to biodiversity and nature dynamics, these are things that, of course, we cannot model directly from the climate science, natural science side. We can model the carbon cycle and the interactive vegetation and things like that. When it comes to actual nature and biodiversity, there we have to link to other communities, and that is ongoing. But I think this is recognized as so how do the changes in the climate and the changes in nature, how do these interact to give us our new future conditions? This, I agree, is a major knowledge gap. We need all the reminders that we can get that this is something we really have to work more on.
Stefan, any thoughts from your side?
Yes, well, good points here. I think the second one, biodiversity and dynamics in the nature and interaction with climate, is a good one, I think, because well, in a way, if we think about polar regions, these are kind of snow and ice dominated regions. And it's obvious, like if you are having some warmings, you are having massive physical changes because ice and snow is melting. So, and then what's happening with these systems that are dependent on these. So I think we are actually dealing with regions that are like undergoing vast dynamics and vast changes, and it's very complex system. So it's not easy to understand. So I agree that kind of maybe understanding, even understanding the hydrological changes assigned with changes in permafrost, thaw, and ice conditions. That is all very, very complex. But understanding what's then actually happening with the vegetation that is living in these areas is difficult. Yes, it's complex and demanding. So it's certainly something where we cannot say that we know everything already. Yeah. And then I agree with Bjørn on the last point. That's I think there's quite a lot of expertise in the CRiceS project on these topics, and I hope that CRiceS. Well, I'm actually fairly sure that CRiceS will make some contributions on improving the understanding of these processes.
Thank you so much to both of you, and thank you to everyone who joined in today to this webinar from CRiceS. I will just maybe give the floor back to you, Risto, to see if you have any closing remarks.
Yes, thank you also from my side to Stefan and Bjørn for giving us very interesting insights to the hazards and risks in the polar context, and of course to the audience for feedback and questions. Thanks also to Astrid, Adeline, and Eric for setting things up for this nice webinar. So we in CRiceS will of course pick up on the momentum from here and the thoughts, and when we are further processing towards, as Stefan Bjørn mentioned, taking this further in the project itself and getting a little bit deeper into the analysis of hazards and risks. Also, we will have some more dedicated workshop still for our stakeholder group later in June. But thank you to everybody joining, and have a nice summer